Hey guys, welcome back to another episode of the Real Hacker Hours podcast. Today I'm going to continue with Semgrep rules. Effectively, what my end goal is here is to effectively just like write a tool that can effectively leverage Semgrep in a way that will allow me to narrow down code that I need to reverse in a target to identify, oh hey, these are the vulnerable parts. Right now, effectively what this part here is, it's effectively just a wrapper for Semgrep, and it will output the Semgrep output as JSON, then scan it in, and then enumerate it that way. And let me pull it up. Cool. So, okay. Now, what I want to do is I have some rules in place, and I have some example source code. I'm probably going to do a bit of development on this to get it to a point where I can effectively run it against a lot of different targets and have it find stuff. One thing I'll probably need to do in order to do that is write some test cases. So I'm going to be working on just having that functionality here, so I could then like build a ton of functionality in order to find potential bugs. So right here, I have it that effectively call. So actually, let me just run it once. Yeah, I'll run it. Dump the semgrep output as JSON into this file. Then it will scan open the file and then effectively just parse it out. How do I want to do this? Well, for testing, I could have it like this. Well, test rules. Okay, so currently the data structure I have for this will be that each individual result, I have a class for that, I have a class to effectively like store the results in it. The each result object currently has these data values established for it, the check ID, so what type of check it is, and which I believe that's where it is in the source code file. Path, which is the source code file that it's scanning it from, message and severity attached to it, and also extra, which that includes some specific. Well, no, extra is just where these parts are stored. Okay, cool. So, how can I do testing? What I could do is how I plan on having it done is have all the rules run against the example source and just effectively have it that I just define, oh hey, these types of results should be seen on these files, and then I can just compare that against what is actually seen. And if there's no differences, then it operated just as I expected. If there is a difference, something is wrong, I need to investigate. So, okay, now that that's been established, I could have... Actually, I probably will want to... Actually, yeah, I want to... Hang on one second. Okay, yeah, I'm going to want to make a function in here for that. Let's just call it def run tests. For this, actually, we can make this a part of the results parser self. So what we can do is... we're going to need to, this will probably be in the form of an output file once it gets to a certain point. However, for now, I'm just going to have it as a dictionary where it's just like, well, how do I want to do this? There's, how I'm thinking of, first off, is we can compare the total counts. Well, I'm going to pause a second and think how I want to do this. Okay, so I thought of how I'm going to want to do testing. How I'll do it is I will have a dictionary. This dictionary will model effectively what the proper results should be. the key to the dictionary, actually, can I do this? Hang on a second, let me just check. X equals. I'm wanting to see if I can. So I can't hash a list. I forgot that I couldn't do that. Give me one more second. Okay, cool. So instead of doing a list, what I'm wanting to do is just take the check ID and append it somehow to the path through some sort of like string concatenation. I'm not sure how, and effectively take that and use that as a key to the dictionary. And what the value will be is the number of effective, the number of checks that, or number of times a rule should be flagged within that file. So let's say if I have a rule for sprintf with %s and it should be flagged 3 times in a file, that dictionary key value should be the key should be the rule concatenated to the path or some variation of that, and the value should be 3. And what I'll do is I will iterate through all of the results that I got. For each result, I will check, oh hey, first, does the key exist in the dictionary? It doesn't, something's wrong, and raise an error. If it does exist, take that number, subtract it by 1. If it goes below 0, that's a problem. Raise a flag, or not raise a flag, raise an error. And then after I'm done iterating through all the results, I will iterate through that array, checking that all of the values are indeed 0. If they are, cool, go ahead. If not, something's wrong. Also, I just realized there's probably like several different ways you could use some OP code algorithms to improve that. Not too worried about that right now. So, how I'm going to do this. Requiem test cases. I am going to, let's forget about this file for now, Requiem test cases. I am going to save this as a Python file that will effectively just be, here I'll show you, cases equals. This will effectively just be a ton of, well, it's going to be effectively a function that's like concatenate of some sort. And it's going to take check ID string followed by the path, which is a string. And it's going to return these check ID plus path. This function is just going to concatenate the check ID and path. And check ID 5 concatenate. Okay, yeah. Effectively, what this file is going to be, is just going to be two things: a function which actually handles the concatenation between the check ID and the path. Also, the reason why it's these two values instead of anything else is these two things should uniquely identify the amount of times a rule is flagged within a single thing. Also, not the message and severity. The message should also be somewhat as unique as a check ID, where the check ID is definitely the unique identifier for it. Severity, that's, you'll find that with a bunch of different things, so I'm not really too worried about that right now. Also, the and, where it signifies where in the source code file it is. I don't want to judge based upon that right now, just in case if I go in there and like add or remove a single line, I don't want it to ruin a ton of different test cases that to then go back and correct. So let's go ahead and take a look at the source code we have. Example source fgets So the first thing is the check ID, second thing is the path. F gets 000.c. I think I might have documented what should get flagged by what. And I did. Thank you. Former self. Okay, cool. I'm just gonna make sure that these rules, that these check IDs are accurate and current. For that, we can go to rules, f gets static size overflow. Yep, cool. So this makes it really easy. We could just that should get flagged once. That should get flagged once as well. F gets 001 shouldn't be flagged by anything. F gets 02 should be flagged by actually same exact thing. So I can just copy that, paste it there. And then F gets 4 variable right size and destination static. So the variable right that goes there. Okay, that's it for F gets stir copy. This is going to be a bit easier. Yeah, this is part of the boring part of tool development, but I want a good tool that I can use. Okay, so I'm going to pause it as I fill in the rest of these. Okay, I'm back. So I believe I have filled in all of the test cases and what the corresponding rules that should get flagged by them. So let's go ahead and try to run this. So let's import Requiem test cases. Cool. And let's first just try running Requiem to make sure that imports it correctly. No, what is... Oh. Yeah, can't have a function there. Okay, cool, so it runs. Now, let's try to write a run test function. So we're going to do for result and self.results. Now, what do we need? We need the check ID and the path. For that, we can do Requiem test cases.concat check ID equals self.path. I'm just defining as variables so we don't have a line that's like 3,000 characters long. Self.path. And check ID followed by path, so let's follow that convention. Okay, yeah. I'm making sure to call the concat function from here. That way, I just have, if I want to change how I do this, I can just change it in one spot. So, Requiem test cases key equals that. And how can I'm gonna check real quick to see how we can check to see if a dictionary exists. No, if a key exists in a dictionary in Python. Let's just make a few simple values. 0, 2, I believe it's 0 key value in dictionary. Yep. So we can do if key not in Requiem test cases dot test cases. We'll have to raise. What are the different? I'm not sure what error to raise in here. I forget all the Python errors. I'm just going to do an attribute error. Found. What message do I want to put here? Found. Oh, rule was flagged that wasn't defined by test cases. Cool, but if I'll raise attribute error and stop execution of the code, but if we reach here, that means that this dictionary does have the key, so I can then check if Requiem test cases is greater or less than 0. Just gonna copy this error message for now. I'll figure out any error messages after I get this working. So now that we have that established, this is a check to ensure that we did not flag a rule in a file that we did not define that there are any rules for. This is a check to see that we aren't flagging a rule 3 times in a file that we only wanted it like flagged 2 times or 1 time. And this right here is where we actually account for that we flagged one instance of a rule in a particular file by decrementing the associated value. Key minus minus. I believe that will work. Let me just test it real quick. Oh, wait, no. That is not how you declare a dictionary. Okay, so that's how I need to do it. Equals current val equals current val minus equals 1. And I use current val so I don't just have one line of code that's super long. So this should iterate through all the way, and then I can for result. Okay, so we iterated through all of the results once to effectively count the amount of times we flagged everything and correspond that to correspond that to what we wanted it to specify. Now we need to go through and check to make sure that all of the values in the dictionary are set equal to 0. I'm just going to quickly just Google how to iterate through all keys in a Python dictionary, BRB. Okay, I'm back. So instead of iterating through the entire list again, what I do is after I decrement the value, I check again to see, oh hey, did we set it equal to 0? If we did, just go ahead and remove that entry from the dictionary. If we find it in a subsequent check that, oh hey, we also see that we flagged something else, then this check right here will flag it and cause an error. So let's go ahead and see if this works. To do so, I'll add a command line option to specify for this function, but for now I'm just going to do results parser. Wait, no, that's not right. this is the instance of the object we have, and run tests. And let's see if this works. So, oh wait, no. Wrong one. Line 47. First, let's get rid of this print right here because we really don't need it. Print length the requiem test cases dot test cases. Okay, something is not going right. 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. None of these are getting removed. Why is that? Let's first see, is this being ran? No, this is never being ran. Why is it not being ran? Print. Current val. For result and self.results. Is it just not running through this? What is going on? This is a really strange bug. So this function's running. This is not. Why? Results parser. Hang on. Let me make sure. Current rules. Okay, so right now I only have 2. Okay, that might have been what it was. So I didn't have all of the rules in here, but that's still not what the problem is. Wait, is this just never getting ran? Testing. So it's never adding any of them. Okay, looks. Looking at here, we see errors, so it's unable to find a config path none equals rules code. Let's print out this command. Command equals none. Oh, I forgot to specify the rules. Rule 32. Oh, not rule 32. Line 32. Okay, we aren't looking at the results parser class. We're looking at the result path, not path, result class. So we need to change it. Line 38. line 36. Let's print this key. Okay, so it's fgets desk static. Oh, okay, I forgot to change that to that. I think I forgot to save that. Wait. Let's look at this list real quick. Okay, so O4 gets flagged, O2 gets flagged, and O gets flagged. O2 gets flagged by F gets disk static, which I do not have here. And since I know F gets, the checks I have for them in memcopy are pretty similar, I'm going to go ahead and check here, and turns out I was missing one from memcopy too. And let's put that there. Let's run this now. Memcopy disk static. O4. Let's change that. Hopefully this will run without errors now. Nope. Sprintf 1. Is that the one that should get flagged? Okay, both is sprintf 0 and sprintf 1 should get flagged. Let's add that in. Okay, it ran, all the test cases are now passing, so now we have a method for actually testing if our current rules are operating the way we want. This has been about 28 minutes of me setting up test cases, so I'm going to end it off here because you guys are probably bored half to death. Thanks for watching and see you next time.